Hello, in this lecture we will find the value of x in two different methods. In the drawing we have the right triangle ABC. We know that angle ABD equals to alpha, angle ADE also equals to alpha, and angle AEC equals to alpha. And we also know that side BD equals to 3 units, side DE equals to 4 units, and we want to find out the value of EC, that is to say x. We are looking for the value of EC that equals to x. Okay, so first of all I will present to you the angle bisector theorem. The angle bisector theorem is related to triangle. If angle bisector, if we have triangle ABC, triangle ABC can be any triangle, and we know that AD is angle bisector, that is to say AD divides angle BAC, divides this angle to two equal parts. It divides angle BAC to two equal parts, that is to say, if this angle equals to theta, then this angle also will be equal to theta. So angle bisector AD divides angle BAC to two equal parts. It bisects angle BAC, therefore angle BAD equals to angle DAC. Okay, so according to angle bisector theorem, the ratio that angle bisector AD divides BC, that is to say angle bisector AD divides side BC of triangle ABC in a ratio of BD over DC. Okay, that is the ratio that angle bisector AD divides side BC of triangle ABC, and that ratio equals to the ratio between the angle legs. The angle legs are AB and AC, so the ratio that angle bisector AD divides BC equals to the ratio of the angle legs. The ratio of the angle legs is AB over AC. Okay, so again, according to angle bisector theorem, the ratio that angle bisector AD divides BC, that is to say BD over DC, equals to the ratio between the angle legs, that is to say equals to the ratio of AB over AC, because the angle legs are AB and AC. So the ratio between the angle legs, that is AB over AC equals to the ratio that angle bisector AD divides side BC. That is to say, to BD over DC. So I'll write the angle bisector theorem. I will write the theorem actually according to angle bisector theorem. An angle bisector divides the side that it eats in a ratio that equals to angle legs, to the ratio in a ratio that equals to the angle legs. In a ratio that equals to the ratio of angle legs. So I will read the angle bisector theorem again. So the angle bisector theorem states that an angle bisector divides the side that it eats in a ratio that equals to the ratio of angle legs. So I repeat again. The angle bisector AD divides the side that it eats, that is to say BC, in a ratio. Actually, angle bisector AD divides side BC in a ratio of BD over DC, and that ratio equals to the ratio between the angle legs, and the angle legs is AB over AC, so it equals to AB over AC. Again, the angle bisector AD divides side B in the same ratio, side BC in the same ratio as the ratio between the angle legs, that is to say, to AB over AC. So that is to say, BD over DC equals to AB over AC. Okay? So that is the angle bisector theorem. So in the next step we will focus on the right triangle ABE. So in triangle ABE, the right triangle ABE, we know that on the right triangle ABE, we know that AD is angle bisector. Again, on the right triangle ABE, AD is angle bisector. So why AD is angle bisector? Because of the fact that AD divides angle BAC to two equal parts, to alpha and alpha. Therefore, AD is angle bisector in triangle ABE. So, according to the rule of angle bisector, angle bisector AD divides the side that it is, that is to say BE, in a ratio of BD over DE, and that ratio, so angle bisector AD divides side BE, the side that it is, side BE, in a ratio of BD over DE, and that ratio equals to the ratio of the angle sides, and the angle sides are AB over AE, AB and AE, so it is AB over AE. So, according to angle bisector theorem, because of the fact that in the right triangle ABE we have angle bisector AD, then the following equality is true, that BD over DE equals to AB over AE. Okay, but what is the size of BD? The size of BD is 3 units. And what is the size of DE? DE equals to 4 units. It equals to AB over AE. Okay, so here we know that BD equals to 3 units, DE equals to 4 units, and it is equals to AB over AE according to angle bisector theorem. Okay, so in the next step we will define AB as 3K, that is to say AB will be equal to 3K according to our definition, and we will find out the value of AE. So we will substitute AB in equation number 1 by 3K, because AB equals to 3K according to our definition. We will get that 3 over 4 equals to AB equals to 3K, so it is 3K over AE. So here we will multiply this equality by AE, and we will get that 3 over 4 times AE equals to 3K. We multiply this equality by AE, and we got that 3 over 4 times AE equals to 3K. Here we will multiply this equality by 4. We will get that 3AE equals to 4 times 3 is 12K. So here we will divide this equality by 3 in order to get the value of AE. We will get that the value of AE is actually 12 over 3 is 4, so AE equals to 4K. So actually we found out that if AB equals to 3K, then AE will be equal to 4K. Okay, so in the next step we will continue to focus on the right triangle, triangle ABE. According to Pythagoras theorem, in the right triangle ABE, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square plus BE square equals to AE square. Again, AB square plus BE square equals to AE square. AB square plus BE square equals to AE square. That is according to the Pythagoras theorem. Okay, but what is the value of AB? AB equals to 3k. That is according to our definition. So we'll substitute AB by 3k. It is 3k square plus BE. What is the value of BE? What is the value of BE? BE equals to 3 plus 4. That is to say to 7. So BE equals to 7. So here we have 7 square. BE square is 7 square. Equals to AE. What is the value of AE? AE equals to 4k square. So in total we got that 3k square plus 7 square equals to 4k square. Okay, 3k square is 9k square plus 7 square is 49 equals to 4k square is 16k square. So here we will subtract from this equality 9k square, and we will get that 49 equals to 16 minus 9 is 7. 49 equals to 7k square. So we found out that 49 equals to 7k square. Here we will divide this equality by 7, and we will get that k square equals to 49 over 7 is 7. We will take a root out of this equality, and we will get that k equals to the root, to the positive root of 7. Because of the fact that k represent the size of a side of a triangle, it must be a positive number. Therefore, k equals to the positive root of 7. And we know that AB equals to 3k according to our definition, and AE equals to 4k. AE equals to 4k. So we know that k equals to root 7. So here AB that equals to 3k, actually it equals to 3 times root 7. And here AE that equals to 4k, we know that k equals to root 7, so AE equals to 4 times root 7. Okay? So we actually found out the values of AB and AE. So in the next step we will focus on the right triangle ABC. On the right triangle ABC, we know that tangent 3 alpha equals to BC over AB. Again, tangent 3 alpha equals to BC over AB. Again, in the right triangle ABC, tangent 3 alpha equals to BC over AB. Okay, tangent 3 alpha equals to BC over AB. What is the value of BC? BC equals to 3 plus 4, that is 7, plus x. That is to say BC equals to 7 plus x. So here we can write down that BC equals to 7 plus x. And we have already found out that AB equals to 3 times root 7. So in total we found out that tangents 3 alpha equals to 7 plus x over 3 times root 7. Okay. In the next step, we will focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, we know that tangents 2 alpha equals to BE over AB. Tangents 2 alpha equals to BE over AB. Okay, on the right triangle, triangle ABE, tangents 2 alpha equals to BE over AB. What is the value of BE? BE equals to 3 plus 4 is 7. BE equals to 7. And we have already found out that AB equals to 3 times root 7. So in total, we found that tangents 2 alpha equals to 7 over 3 times root 7. Okay? Tangents 2 alpha equals to 7 over 3 times root 7. Okay, tangents 2 alpha equals to 7 over 3 times root 7. And in the next step we will focus on the right triangle, triangle ABD. On the right triangle, triangle ABD. We know that tangents alpha equals to BD over AB. Tangents alpha equals to BD over AB. Okay? Tangents alpha equals to BD over AB. What is the value of BD? BD equals to 3 units. And we have already found out that AB equals to 3 times root 7. So in total, we found out that tangents alpha equals to 3 over 3 times root 7. Okay? So we actually found out the values of tangents 3 alpha, tangents 2 alpha, and tangents alpha. Okay, so we also know that tangents 3 alpha equals to tangents 2 alpha plus alpha And in order to find out the value of tangents 2 alpha plus alpha, I will present to you a new trigonometric identity of tangents a plus b. Actually, tangents a plus b equals to tangents a plus tangents b over 1 minus tangents a times tangents b. Again, tangents a plus b equals to tangents a plus tangents b over 1 minus tangents a times tangents b. So we will use this trigonometric identity in order to find out the value of tangents 2 alpha plus alpha. So here we will get that tangents 3 alpha equals to tangents 2 alpha plus alpha, and the value of tangents 2 alpha plus alpha, the value of tangents 2 alpha plus alpha according to this trigonometric identity will be equal to tangents 2 alpha plus tangents alpha over 1 minus tangents 2 alpha times tangents alpha. Okay? Tangents 2 alpha plus alpha equals to tangents 2 alpha plus tangents alpha over 1 minus tangents 2 alpha times tangents alpha. This is according to this trigonometric identity. But we have already found out that tangents 3 alpha equals to 7 plus x over 3 times root 7. Tangents 2 alpha equals to 7 over 3 times root 7, and tangents alpha equals to 7 over 3 times root 7. So we will substitute the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha in this equality by the value that we have already found out for tangents alpha, tangents 2 alpha, and tangents 3 alpha. So we found out that the value of tangents 3 alpha is actually 7 plus x over 3 times root 7. It equals to tangents 2 alpha. The value of tangents 2 alpha is 7 over 3 times root 7 plus tangents alpha. The value of tangents alpha is 3 over 3 times root 7, all divided by 1 minus tangents 2 alpha is 7 over 3 times root 7 times tangents alpha is 3 over 3 times root 7. Okay? So here, in order to have a common factor with this expression, we will substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7. Okay, and we will get that seven plus x over 3 times root 7 equals to, here we have 7 plus 3 is 10, 10 over 3 times root 7 divided by, here we'll substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7. Okay, so we substituted 1 by this expression equals to 1. Okay, and in this way we actually have a common factor with this expression. So here we will have 7 times 3 is 21. So in total we got this expression. Here we will move 3 times root 7 times 3 times root 7 to the numerator, and we will move this expression to the denominator, and we will get that seven plus x over 3 times root 7 equals to 10, and we will move this expression to the numerator. 3 times root 7 times 3 times root 7 divided by 3 times root 7. Here we will move this expression to the denominator, so it will be 3 times root 7 times 3 times root 7 minus 21. Okay, so here we have 3 times root 7 in the numerator, and we have 3 times root 7 in the denominator, so we can cancel 3 times root 7, and what is left after we cancelled 3 times root 7? We have here 7 plus x over 3 times root 7 equals, here we have 10 times 3 is 30, 30 times root 7 over, here we have 3 times 3 is 9, and root 7 times root 7 is 7, and 9 times 7 is 63. So here we will have 63 minus 21. So in total we got this expression, and we will multiply this expression by 3 times root 7, and we will get that 7 plus x equals to 30 times root 7 times 3 times root 7 over 63 minus 21 is 42. Okay, so in total we got this expression. So here 30 times 3 is 90, and root 7 times root 7 is 7, and 90 times 7 is 630. So I will write it down. 7 plus x equals to 630 over 42. Here 630 over 42 is 15. So I write it down. We got that 7 plus x equals to 15. So here we will subtract from this equality 7, and we will get that x equals to 15 minus 7 is 8. So we found out that the value of x is 8 units. Okay, the value of x is 8 units. Here the value of x that actually equals to EC is 8 units. X equals to 8 units. So we finished with the first method. In the next step I will explain, we will find out the value of x. Actually we will find out the value of EC that equals to x. We will find out the value of EC that equals to x according to the second method. So in the second method we will do a construction. We will extend BD by 3 units. Okay? And we will define this point as point M. We extended BD by 3 units, so MB equals to 3. Okay? And then we will join together points A and M by a straight line. And actually DM is a straight line. DM is a straight line. And we have a rule that the sum of the angles on a straight line equals to 180 degrees. The rule states that the sum of the angles on a straight line equals to 180 degrees. I will read the rule again. The rule states that the sum of the angles on a straight line equals to 180 degrees. Okay, so we know that DM is a straight line. Therefore, the sum of the angles on the straight line DM equals to 180 degrees. We will focus on at point B. The sum of the angles at point B on the straight line DM equals to 180 degrees according to this rule. So what we have at point B? At point B we have here 90 degrees. It is given us in the equation that this angle equals to 90 degrees. Plus the size of angle ABM must be equal, the sum of those two angles, 90 degrees plus angle ABM, must be equal to 180 degrees, according to the rule that the sum of the angles on a straight line equals to 180 degrees. Okay, this equality is according to this rule. Here we'll subtract from this equality 90 degrees, and we will get that the size of angle ABM is actually equal to 180 degrees minus 90 degrees is 90 degrees. So we found out that the size of angle ABM is 90 degrees. That is to say, it is a right angle. It equals to 90 degrees. So here we have actually two right angles. So in the next step, we will focus on those two right triangles, on triangle we will focus on triangles, the right triangle A and B. And the right triangle ABD. We will focus on those two right triangles. We know that MB equals to BD equals to 3 units. MB equals to BD equals to 3 units. Okay, MB equals to BD equals to 3 units. MB equals to 3 units according to our construction. Okay, and we also know that those two angles are right angles, they are equal to each other. So angle ABM equals to angle ABD, and both those two angles are equal to 90 degrees. Okay, we proved that this angle equals to 90 degrees and this angle equals to 90 degrees according to what is given us in the question. So angle ABM equals to angle ABD equals to 90 degrees, and side AB is a common side. It belongs to both triangles, so AB equals to AB. It is a common side. It belongs to both triangles. So AB equals to AB. It is a common side. So we actually proved that triangle AMD can go into triangle ABD according to side angle side rule. Those two triangles can go into each other according to side angle side rule. So triangle AMB congruent. This is the size of congruent, the sign of congruent. Triangle AMB congruent to triangle ABD according to side angle side rule. Okay. So what is side angle side rule? If you prove that two sides and the angle between those two sides of one triangle are equal to two sides and the angle between them of the other triangle, then you proved that those two triangles can go into each other according to side angle side rule. Okay, so those two triangles can go into each other. Therefore, we can conclude from the fact that those two triangles can go into each other that those two angles are also equal to each other. That is to say, angle BAD equals to angle MAB and angle ABD equals to alpha, so angle BAD equals to angle MAB according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, corresponding angles in congruent triangles are equal to each other. Again, angle BAD equals to angle MAB according to the rule that corresponding angles in congruent triangles are equal to each other. Actually, those two triangles can go into each other, therefore the corresponding angles, that is to say those two angles, will also be equal to each other. Okay, so we know that angle BAD equals to alpha, so angle MAB will be also equal to alpha according to this equality. So angle MAB will be also equal to alpha because those two angles are equal to each other. Okay, and from the fact that those two triangles can go into each other, we can conclude that side AM of triangle AMB is equal to side AD of triangle ABD. Those two sides are equal to each other. AM equals to AD. AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. Corresponding sides in congruent triangles are equal to each other. Again, AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. Again, those two triangles can go into each other, therefore the corresponding sides AM and AD will be also equal to each other. So if we define angle AM as Y, then angle AD that equals to AM will be also equal to Y. Okay, here AM equals to AD equals to Y. So in the next step we will focus on triangle ADC. So in triangle ADC, we know that AE is angle bisector. Again, on triangle ADC, AE is angle bisector. So why AE is angle bisector? Why AE is angle bisector on triangle ADC? Because of the fact that AE divides angle DSC to two equal parts, alpha and alpha. Therefore, AE is angle bisector on triangle ADC. So according to the rule of angle bisector, the angle bisector AE divides side DC that is to say DE over EC okay, angle bisector AE divides side DC in a ratio of DE over EC, and that ratio equals to the ratio between the angles sides, that is to say the ratio between the angle sides are AD over AC. So we got this equality that the ratio that angle bisector AE divides side DC, that ratio equals to DE over EC, and that ratio also equals to the ratio between the angle legs, that is to say to AD over AC. Okay? But what is the value of DE? DE equals to 4. And what is the value of EC? EC equals to X. And what is the value of AD? AD equals to Y over AC. So in total we got that 4 over X equals to Y over AC. Here we will multiply equation number 1 by AC, and we will get that 4 over X times AC equals to Y. So here we will multiply equation 1 by X, and we will get that 4 times AC equals to Y times X. So here we will divide equation number 1 by 4 in order to get the value of AC. And we will get that AC equals to Y times X over 4. Okay, according to equation number 1, AC equals to y times x over 4. So in the next step, we will focus on triangle AMC. So in the big triangle AMC, we know that AD is angle bisector. Again, in the big triangle AMC, AD is angle bisector. In triangle AMC, AD is angle bisector. So why AD is angle bisector in triangle AMC? Because of the fact that AD divides angle MAC to two equal parts. It divides angle MAC to 2 alpha and 2 alpha. Alpha plus alpha is 2 alpha. So because of the fact that angle bisector AD divides angle MAC to two equal parts, angle AD is defined as angle bisector. So, and according to the rule of angle bisector theorem, the ratio that angle bisector AD divides MC is actually MD over DC. And that ratio equals to the ratio of the angle legs. And the angle legs is AM and AC. So the ratio between the angle legs is AM over AC. Again, angle bisector AD in the big triangle AMD divides side MC in a ratio of MD over DC, and that ratio equals to the ratio between the angle legs, and the angle legs are MC and AC, so the ratio between the angle legs and AM over AC is AM over AC. Okay, the ratio that angle bisector AD divides side MC of triangle AMC is MD over DC, and that ratio equals to the ratio between the angle legs, that is to say AM over AC. Okay, so here, what is the value of MD? The value of MD is 3 plus 3. MD equals to 3 plus 3, that is to say to 6. And what is the value of DC? DC equals to 4 plus X. 4 plus X. All equals to AM. What is the value of AM? AM equals to Y, according to our definition, over AC. So we got this equality according to angle bisector theorem. Here we will multiply this equality by AC, and we will get that 6 times AC over 4 plus X equals to y. So here we will multiply equation number 2 by 4 plus x, and we will get that 6 times AC equals to y times 4 plus x. We will divide this equality by 6, and we will get that the value of AC equals to y times 4 plus x over 6. That is equation number 2. And from equation number 1, we know that AC equals to y times x over 4. Okay, so we have the value of AC in two equations, in equation number 1 and equation number 2. So here we will create equation number 3 that says that AC equals to AC. Okay, AC equals to AC, and we will substitute AC by the value of AC that we found in equation number 1, and in the other side of the equality we will substitute AC by the value that we found in equation number 2. So we will get that AC is actually, according to equation number 1, is yx over 4, and it equals to AC according to equation number 2, and according to equation number 2, AC equals to y times 4 plus x over 6. So in total we got this equation number 3. So here we will multiply this equality by 4 and by 6, and we will get that six times yx equals to 4 times y, 4 plus x. We will divide this equality by y, and we will get that 6x equals to 4 times 4 plus x. Here we will open the brackets in equation number 3, and we will get that 6x equals to 416 plus 4x. We will subtract 4x from equation number 3, and we will get that 2x equals to 16. Here we divide equation number 3 by 2, and we will get that x equals to 8 units. So we found out that the value of x is 8 units. X equals to 8 units. So we can write here that x equals to 8 units, or in other words, the value of EC that equals to x is 8 units. Okay. So we finished to find out the value of x according to method 2. In the next step I will summarize the lecture. Actually we wanted to find out the value of x, that is actually EC, and we know that angle MA, angle BAD equals to alpha, angle DAE equals to alpha, and angle EAC also equals to alpha. And we also know that BD equals to 3 units, DE equals to 4 units, and triangle ABC is a right triangle because of the fact that angle ABC equals to 90 degrees. And we want to find out the value of x, that is actually EC. Okay? So actually I presented to you the angle bisector theorem. The angle bisector theorem relates to a triangle that has angle bisector. In this example we have triangle ABC with the angle bisector AD. The angle bisector AD divides angle BAC to two equal parts, that is to say to theta and theta. And according to angle bisector theorem, an angle bisector divides the side that it hits in a ratio that equals to the ratio of angle legs. So the angle bisector AD divides BC in a ratio that equals to BD over DC. That is the ratio that angle bisector AD divides side BC to the ratio of BD over DC, and that ratio equals to the ratio of the angle legs, and the angle legs are AB and AC, and the ratio between the angle legs is AB over AC. So the angle bisector AD divides side BC in the ratio of BD over DC, and that ratio equals to the ratio between the angle legs, and the ratio between the angle legs is AB over AC, or in other words BD over DC equals to AB over AC. Okay? So we in triangle, the right triangle ABE, we have angle bisector AD. AD is angle bisector because of the fact that it divides angle BAE in triangle BAE to two equal parts, to alpha and alpha. Therefore AD is angle bisector in the right triangle, triangle BAE. Therefore, according to angle bisector theorem, the ratio that angle bisector AD divides side BE, that is to say BD over DE, equals to the ratio between the angle legs, equals to AB over AE. Okay, again, the ratio that angle bisector AD divides side BE is BD over DE, and that ratio equals to the ratio of the angle lengths, and the ratio of the angle lengths is AB over AE. So the ratio that angle bisector AD divides side BE is BD over DE, and that ratio equals to the ratio of the angle lengths, and the ratio of the angle lengths is AB over AE. That is to say, BD over DE equals to AB over DE. And we know that BD equals to 3 units, DE equals to 4 units. So BD over DE is 3 over 4, and it equals to AB over AE. We defined AB as 3K, and so we substituted AB in this equality by 3K, and we found out that if AB equals to 3K, then according to this equality equation number 1, AE must be equal to 4K. Okay, so we know that AB equals to 3K and AE equals to 4K. And then we implemented the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars in the right triangle ABE. That is to say, AB square plus BE square equals to AE square. AB square plus BE square equals to AE square. That is according to Pythagorean theorem. And we know that AB equals to 3K, BE equals to 3 plus 4, that is to say to 7, and AE equals to 4K. It is given, we already found out that AE equals to 4K. So we got this equality, and we found out that from this equality that K equals to root 7 units. K equals to root 7 units. So we know that AB equals to 3K and AE equals to 4K, and we have already found out the value of K. Okay, so we can write that AB equals to 3K and K is root 7. That is to say, AB equals to 3 times root 7. And also here we know that AE equals to 4K and K equals to root 7. So AE will be equal to 4 times root 7. So we found out that AB equals to 3 times root 7 and AE equals to 4 times root 7. And then we focus on the right triangle ABC. We know that in the right triangle ABC, tangents 3 alpha equals to BC over AB. Okay, tangents 3 alpha equals to BC over AB. What is the value of BC? BC equals to 3 plus 4 plus x. That is to say, BC equals to 7 plus x. Okay, BC equals to 7 plus x, and we have already found out that AB equals to 3 times root 7. So in total we got that tangents 3 alpha equals to 3 plus x over 3 times root 7. Then we focused on the right triangle ABE. On the right triangle ABE, tangents 2 alpha equals to BE over AB. Okay, in the right triangle ABE, tangents 2 alpha equals to BE over AB. And what is the value of BE? BE equals to 3 over 4, to 3 plus 4, that is to say to 7. And so BE equals to 7, and we already found out that AB equals to 3 times root 7. So in total we got that tangents 2 alpha equals to 3 over 3 times root 7. And then we focus on the right triangle ABD. On the right triangle ABD, we know that tangents alpha equals to BD over AB. On the right triangle ABD, tangents alpha equals to BD over AB. But we know that BD equals to 3 units and AB equals to 3 times root 7. So in total we got that the value of tangents alpha equals to 3 over 3 times root 7. So we found out the values of tangents 3 alpha, tangents 2 alpha, and tangents alpha. Then we also know that tangents 3 alpha equals to tangents 2 alpha plus alpha. Okay? And in order to find out the value of tangents 2 alpha plus alpha, I presented to you trigonometric identity that states that tangents A plus B equals to tangents A plus tangents B, tangents A plus tangents B over 1 minus tangents A times tangents B. Okay, so we use this trigonometric identity in order to find out the value of tangents 2 alpha plus alpha. And according to this trigonometric identity, tangents 3 alpha that equals to tangents 2 alpha plus alpha equals to tangents 2 alpha plus tangents alpha over 1 minus tangents 2 alpha times tangents alpha. Then we substituted the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha by the values that we have already found out, and we got this equality. And in this equality we have only one variable that is missing, that is x, and x is the missing variable that we want to find out. So from this equality, I don't want to repeat on this simple calculation. So from this equality we found out that the value of x according to method 2 is 8 units. So we found out that the value of x, that is actually EC, equals to 8 units. Okay, so we found out in both two methods that the value of EC that equals to x is 8 units. Okay, thank you very much.